Gyroscopes. They may just look like nerdy toys, but they harbor an extremely unique power that we're going to explore with rotational mechanics and rotational dynamics. If I were to place this gyroscope on my palm and let go, it falls over. But if I give it a spin, try it again, it stays. Why is that? Let's find out. To begin, let's focus on an object undergoing uniform circular motion from a mechanics perspective. We are now going to imagine that the keys at the end of this lanyard are traveling in an infinite amount of straight lines around the circular path, rather than just in a circular path. The lanyard is causing a centripetal acceleration, or changing the velocity's direction of the keys towards the middle, and thus, as we will see right here in this freeze frame, the keys will travel upward. That's their velocity. So if I were to let go of the lanyard, it would travel upward no matter what, and that is modeled. So its momentum, the linear momentum of the keys, points in the direction tangent to the path, the circular path. Next, we're going to look at why objects rotate using torques. We have a door with a pivot point located along this line. To open the door, I'm going to apply a force inward, some distance away from the pivot point. This will create a torque in the counterclockwise direction. It's pretty intuitive. Now let's represent the idea of a net torque using this highlighter. Gravity is exerting a force on every single point along this highlighter, trying to tip it over along this axis of rotation. But it's not rotating, obviously. Why is this? It's because all the torques that gravity is exerting cancel each other out at every single point around the highlighter. Thus, the object will not rotate because there is not a net torque. However, if I were to move the highlighter like this, and increase the force of gravity this way, decrease it in this direction, there will be a clockwise torque, like that. Let's apply everything we've talked about to this gyroscope. Let's say that the disc is rotating clockwise. Therefore, the linear momentum of a piece on the edge of the disc will point to the left. However, torque by gravity will exert a force downward in this direction. But as we saw earlier, the gyroscope will not fall straight down and it will not travel this way. Why won't it? It's because the sum of these vectors, the resultant vector, will point in this direction, causing it to rotate 90 degrees ahead of where it is at the previous point in time. And that is why the gyroscope precesses like this.